So we're doing variation today. Super fun stuff. I would say for the most part we have done variation at some point in our lives. So I want to say we've probably done direct variation and inverse variation. We haven't done like variation with an nth power or joint variation. I know pre-calc probably did last year, but I'll do it. Never did. Okay. Does anybody remember what direct variation is? So direct variation is basically, I'm going to say something, because it could differ with every like problem, story problem, is a constant multiple. Of something else. So what does this constant multiple actually mean? Well, what is constant? Stays the same, so typically in constant we have just like a number. And what does multiple mean? Yeah, so I see like multiplying it like times. So we're basically multiplying some number to a changing variable to get something else. So basically this is saying y equals k times x. So this is where the constant multiple comes in, k times x. So k is our constant. We're multiplying it to our x value, which is like our dependent independent variable. We can change it. Y is dependent. So you'll see phrases like y is directly proportional to x. Proportional. Or they'll have some way of saying direct variation in there in some form or another. So whenever you see direct proportional, you should see the equation and write it down so that we can solve that k value. So that k is just going to be a number that you need to figure out. Does anybody know what a direct variation graph looks like? Let me next this to the first power, so it's going to be a straight line. I don't have a y-intercept, so it's just the origin. So basically, whatever k is, that's going to be the slope of the line. Nothing crazy. If you have a problem like that, that's why I drew it out, thinking of graphs. So direct variation, our phrase could be constantly changing. So it's always going to start like y is directly proportional. We could change how we say the x value. So it could be like to the second power of x, or the third power of x, or the square root of x. So this x could be changing with the powers. So just be careful if it is the square of x. You need to write y equals k squared, kx squared. If they set the square root of x, then it's y equals k square root of x. Okay? So write down whatever they say, so that way your equation matches up to what it's supposed to be. So that's direct variation. Inverse variation is basically the opposite of direct variation. So direct variation was multiplying. Inverse variation is dividing. So my inverse variation equation will look like this: y equals k over x. So basically we have a rational function, which is what we've been doing. But same thing, they're going to have some phrase. Y is inversely proportional to x. Right? And then x could be changing as well. It could be x to the second power, or the cube root of x, or something with x. Okay? So just be careful when you're reading it out. Don't forget all the little things that they might throw in there. And if I was graphing this, what would it look like? Yeah, it's going to be like those graphs that we've been doing this whole time. They kind of shape like an L. I wish there was like a name for these, like a parabola or cubic. Rational, there's no like name that I know of. Okay. And then joint variation. So joint is just meaning we're combining two things together. So this is going to be a product of many variables with a constant. So our standard format is like y equals a times x times maybe like w or z or whatever variable. That's going to be a k, so we're remaining consistent. I use a k with the other ones. So k is our number that's going to be in there for whatever it is. So we could have more than just two variables. We could have 3, we could have 4, we could have 5, we could have as many as they actually describe. But the phrase that they'll say is y is jointly proportional. Proportional to x and w. And honestly, they don't always put jointly proportional. They might say like directly proportional to x and w. So then no, it's a joint, so they're multiplying together. Okay. So here's our first example. X and w, regular variables. So if m varies shortly as x and y, and n equals 10, when x is 2 and y is 14, find m when x is 21 and y is 8. So in variation problems, they give you a lot of information, which it looks kind of crazy, but we should write out the equation first, so that way I can use the equation to solve for m, which is what we actually need to do. Thank you. So does anybody know how this would like start out based on like the first phrase? Sorry, what did you say? Okay. Which looks like? And I'm going to use x times y instead. So this is our like setup, okay, which is based on this first phrase. It always goes in order, like they're not very creative, so put your variables in order. We always need to plug in our k value because we have a constant that we're always going to have in a variation problem. We need to figure out what this constant is before we can do like this very last part. So this information, the 10, 2, and 14, we're going to substitute in and solve for m to actually write my variation equation. So m equals 10 is going in, k is what we're trying to find, 2 is going in, and 14 is going in. Yeah, the first set of information goes together. This is a lovely fraction. So solving for k, we have dividing by 28. And what is 5/14? Okay, so when you have this, I just go back up to what we started with, and I can write my variation equation as m equals 5/14 xy. So this equation is true for whatever information they give us, but now I can use it with these two numbers to actually find what m is. So now we're just substituting back in 5/14 times 21 times 8. And then whatever that is. About 60? Eli says yes. Meadow says yes. Okay. So those aren't too bad. A lot easier than the rational functions. Well, less work. We have one more example. So we just have 4 variables instead of 3. The same thing, we should find our variation equation and then use the equation to substitute in. Okay, so what's my variation equation with all the variables in it? Well, we're starting with A, right? So it has to be A equals, at least. So they say directly proportional to start, so that means we're multiplying. And we're multiplying these in conjunction with each other, m and n squared. And whenever I throw my variables in, I should always have my constant that I need to find. But then they also say inversely proportional. Inversely proportional means a fraction. So now everything in the numerator is now being divided by this last thing, y to the third. So this is my variation equation setup. And first we need to find k before we can find a, which is what they're actually asking us for. Okay, once you have this, we're plugging in a is 9, 4, 9, and 3. And simplifying. So hopefully this comes out nicer than what it's looking. Um, 81 divided by 27 is like 3. Taking a shot in the dark. So then the 4 times 3 is 12, and I can divide by 12 to both sides. So that reduces to 3/4. Okay, so that's my constant multiplier. And I mean, they never really asked for the equation, so I'm just going to leave it looking kind of weird. Typically, I never want a fraction, but this isn't my final answer, so I'm just going to leave it. Okay, so now we can plug in 6, 2, and 5 into my variation equation. This isn't going to simplify nicely, that's why I'm calling. So in the numerator, like the 2 squared and the 4 in the denominator are 3/4, those are canceling, they would divide out. So numerator, you just have 3 times 6, which is 18. And 5 to the third is 125. And then since 5 to the third was 5 times 5 times 5, 5 does not go to 18, so this is the answer. So that doesn't simplify. Interesting. Okay. So there we have it, folks. Tomorrow we're doing more story problems with variation. Just to make it more interesting. No. Mm-mm. Yep. Do we all write this down?
And my water bottle itself.
Yep.